Oh, hello. Welcome to J-Pod's Talk. 2 years, 6 months, and 16 days ago, the Fukushima nuclear disaster wreaked havoc on the country of Japan and exposed huge amounts of dangerous radiation. As a result, countries across the world are reconsidering the viability of nuclear energy as a fuel source. Nuclear energy is one of the cleanest fuel sources today and will exist long after coal and oil have depleted. You can see it here at 13.5% and it's on the rise. Today's program will discuss the threats and benefits of nuclear energy and its future as an energy source. But wait, what is nuclear energy? Nuclear energy is the potential energy in the subatomic bonds of the nucleus. When nuclei are split or fused together, huge amounts of energy are released. We'll be right back with Professor Ramanath to discuss the science behind the nuclear power plant. Welcome back. Here in the studio with us today is Professor Ramanath, a professor of nuclear chemistry at Ramanath University. Welcome to the stage, Ramanath. So, Professor Ramanath, what is the science behind the nuclear power plant?
Well, to understand the science behind a nuclear power plant, you must understand the science behind a nuclear reaction. A nuclear reaction is the transmutation of an atom of an element into a different isotope of the same element, or into an atom of a new element altogether, due to the changing atomic number of the elements. When a proton is added or subtracted, it will change its atomic number and transform into a different element. An example of a nuclear reaction is nuclear fusion, in which nuclei are colliding and fusing together to form a larger and heavier nucleus. An example of such is the Sun, in which the nuclei of hydrogen atoms collide and fuse together to form the nuclei of a helium atom, which is larger and heavier, and a byproduct of this fusion is heat energy. But what occurs in a nuclear power plant is nuclear fission, which is the other main type of nuclear reaction. Nuclear fission is when the nucleus of an atom splits into smaller particles, releasing energy. The energy released by nuclear fission is far greater proportionally to that of the energy released by nuclear fusion, which is why power plants prefer this method. One form of nuclear fission is radioactive decay, a natural process in which a nucleus spontaneously splits. This occurs in 3 types: alpha, beta, and gamma decay. So alpha decay is when a nucleus loses 2 neutrons and 2 protons, otherwise known as an alpha particle or a helium nucleus. The atomic mass is reduced by 4 and the atomic number is reduced by 2, and this changes the element altogether. In beta decay, a neutron is changed into 3 different parts. It is changed into a proton, and this increases the atomic number by 1, but does not change the atomic mass at all. And this also adds positive charge to the nucleus. The second part is that a neutron is turned into an electron, and also into a positron, which is the antimatter counterpart of an electron. The final type of radioactive decay is gamma decay, in which the nucleus is changed from a higher energy state to a lower energy state through the emission of photons, which, as you can clearly see, are both waves and particles. The chemical composition of the nucleus is not altered, but the energy level is clearly changed. Nuclear fission also occurs when a nucleus is impacted by high-speed energy particles. In the controlled case of the nuclear power plant, free neutrons are bombarded into the nucleus in order to create lighter nuclei, more free neutrons, and also to create nuclear energy. The key to a nuclear power plant is the fission chain reaction, which is when free neutrons released from the splitting of other atoms are colliding into more and more nuclei and releasing more and more nuclear energy. And this keeps on going until all of the element is spent.
Next up is Dr. Jay Lin, a nuclear scientist. Welcome. So, Doctor, what is the element you actually use in the nuclear power plant?
The element we actually use in a nuclear power plant is uranium, which is an abundant element. However, for a nuclear power plant, we have to use the isotopes, which is uranium-235.
Why is it you use uranium-235?
There are 2 reasons why we use this uranium-235. The first reason is because it can naturally undergo radioactivity decay. The second reason is because it is fissile and it can undergo induced fission, which means we can take a free neutron and bombard it into the nucleus and split it, and it allows us to get a huge amount of energy. This allows us to get a sustainable chain reaction and effective production of energy.
So where is it found?
It is commonly found in the mountainous area on the western United States in the pitch blende of zinc and iron ore.